Dear students, I am Mahesh Javalkar of MANDAL POLYTECHNIC, and today I am posting my fifth video on the DCET questions on the subject EMI, that is electronic measurement and instrumentation. Okay, we'll start with the first question, or question number 81. The transducers that converts the input signal into the output signal, which is a discrete function of time, is known as dash transducer. Okay. Now input signal is converted to output signal and the output signal is discrete function of time. That means it is a digital value. Okay. That means this is known as a digital transducer. So here from these options, option C will be the right option, that is digital transducer. The transducer that converts the input signal into the output signal, and where the output signal is a discrete function of time, is known as digital transducer. Okay. Then we'll go to the next question, question number 82. Which of the following is a digital transducer? So here the option A is strain gauge. So strain gauge is an analog or transducer which will convert your displacement into resistance. Then we have encoder. Encoder is something which will give you a coding process, and in that it is a digital transducer where the data is coded and it is called as encoder. Okay. Then we have third one, thermistor. Thermistor is sensing the temperature, it will change the resistor, so it is an analog one. And then we have LVDT, linear variable or differential transformer, which when there is a displacement, it will give you a voltage at the output. So here out of these four options, option B, encoder, is a digital transducer because it is going to use the information and then encode that information. So coding is done. Okay. So encoder is a digital transducer. Okay. Then we'll go to the next question, question number 83. An inverse transducer is a device. Okay. Now whenever we speak inverse transducer, so it is just doing the opposite of what an electrical transducer does. Electrical transducer will convert any non-electrical quantity into electrical quantity. Okay. Any non-electrical quantity into electrical quantity is done by transducer. But inverse function of that, which is done by inverse transducer, is any electrical quantity should be converted into non-electrical quantity. So here option A, that is an electrical quantity into non-electrical quantity, will be the correct answer. Okay. Then we'll go to the next question, question number 84. A strain gauge is a passive transducer and is employed for converting what? Okay. So in these options, option A is mechanical displacement into a change of resistance. Option B is pressure into a change of resistance. Option C is force into a displacement. And option D is pressure into displacement. So out of this, the first one, that is mechanical displacement into a change of resistance. This is one what a strain gauge does. Okay, so option A is the right answer. Okay. Then we'll go to the next question. In a wire wound strain gauge or in wire wound strain gauges, the change in resistance is due to what? Okay, so whenever there is a strain gauge, the change in resistance will be directly proportional to the length of the resistance and inversely proportional to the cross section of the resistance. So length and diameter. Okay, so here option C will be the right answer, change in both length and diameter. So in wire wound strain gauges, the change in resistance is due to change in both length and diameter. Okay, so option C is the right answer here. Then we'll go to the next question, question number 86. Quartz and Rochelle salt. Quartz and Rochelle salt belongs to dash of piezoelectric materials. Now quartz and Rochelle salt are the natural elements, natural salts of piezoelectric material. So they come under natural group. So here the option A will be the right one because they are the natural salts. They come under the natural group. So quartz and Rochelle salt belong to natural group of piezoelectric materials. Then we'll go to the next one, question number 87. Piezoelectric transducers are, okay, These options are passive transducer, inverse transducer, digital transducer, and pulse transducer. Okay, so in piezoelectric transducer, we can see that the applied voltage can be converted into mechanical vibrations. Okay, so that is the inverse function. A electrical quantity is converted to a mechanical energy. Okay, so then it can be called as an inverse transducer. That means option B is applicable here. Piezoelectric transducers are inverse transducers. Okay, then we'll go to the next question. Piezoelectric crystal can produce an EMF, that is, it can produce an voltage. Okay, when? So option A is when external mechanical force is applied to it. Option B is when radiant energy stimulates the crystal. Option C is when external magnetic field is applied. And option D is when the junction of two such crystals are heated. So out of these options, the first one is a suitable option, is the right option. When external mechanical force is applied to an piezoelectric crystal, it will produce an electric voltage or EMF, electromotive force. Okay, so option A will be the right answer. Then we'll go to the next question, question number 89. The principle of operation of LVDT, linear variable differential transformer, is based on the variation of what? Now in LVDT, we have one primary winding and two secondary windings. Okay, and in between them there will be a displacement presented, and because of that displacement the secondary windings voltages will change, and that sum you are going to take as the output voltage, and that will indicate what was the displacement. Okay, that means it is working on mutual inductance. It is working on mutual inductance. Your excitation is applied to primary, and that excitation is going to go with a mutual inductance to the secondary, and that will be influenced by movement in the between area of primary and secondary. So there you can have a core movement, and that movement will change the voltages of the two secondary windings. And then when you see that secondary windings, depending on the voltages of the secondary windings, you can understand what was the movement of the core which was in between the primary and secondary windings. Okay, so here it is working on the mutual inductance. Okay, then option B is the right answer here. Then we'll go to the next question, question number 90. Which of the following can be measured with the help of piezoelectric crystal? Option A is force, option B is velocity, option C is sound, and option D is pressure. So we know that a piezoelectric crystal will convert mechanical force into an electrical voltage. So it is option A which is the right answer, force. Force can be measured with the help of piezoelectric crystal. Okay. Then we'll go to the next question, question number 91. LVDT, okay, linear variable differential transformer. Okay, so in a LVDT, the two secondary voltages, okay, now the two secondary are voltages, how do they vary? That has been asked in this question. So option A is they are independent of the core position. Option B is they vary unequally depending upon the core position, and they vary equally depending upon the core position, and are always in phase quadrature. So out of this, we see that if the core is at the center, then both the secondary windings will give you the same voltage. Okay, but if the core moves up or down, then they are varying unequally. There is an unequal voltage in the two secondary windings. So option B will be the right answer, vary unequally depending on the core position. So in a LVDT, the two secondary voltages vary unequally depending on the core position. Okay, then we'll go to the next question, question number 92. Capacitive transducers are normally employed for dash measurements. So your options are static, dynamic, transient, both static and dynamic. Okay, so usually capacitive transducers are used for a movement which is continuously moving, which is dynamic, which is not static, and that dynamic movement will be converted into an electrical quantity by the capacitive transducer. So here the option will be dynamic, B, dynamic. Okay, then we'll go to the next question, question number 93. The transducers which requires an external power and their output is a measure of some variation, such as resistance, inductance or capacitance are called as. Okay. Now the transducer which requires an external power and which varies resistance, inductance or capacitance are passive transducer. Now the transducer which does not require an external power are active transducer. Okay, so here for this statement of question number 93, the answer will be passive transducer. So C, passive transducer. It requires an external power and the output is a measure of resistance or capacitance or inductance variation. Okay. Then we'll go to the next question, question number 94. Hall potential, okay, that is in the Hall effect, whatever there is a flux density variation that will be converted into a voltage, and that voltage is called as Hall potential. Hall potential is inversely proportional to magnetic flux density. Sorry, this statement is wrong because Hall potential is always directly proportional to the magnetic flux density. Therefore, this statement will come as a false statement. So here the answer will be false. B, false. Okay. Then we'll go to the next question, question number 95. Which of the following represents the output of Hall effect transducer? So we know that whenever there is a change in magnetic flux density, then that is converted into an electrical voltage, and that voltage is called as Hall potential. So here the output of Hall effect transducer is Hall potential. So option A is the right answer here, Hall potential. Then we'll go to the next question, question number 96. Hall effect transducer can be used to measure what? Options are magnetic field, option B is angular displacement, option C is linear displacement. Okay, now all types of displacements can vary a magnetic field, and once a magnetic field is varied, it can be converted into electrical voltage, and depending on that electric voltage you can understand what was the variation. Okay, so here option A, B, C, magnetic field or angular displacement or linear displacement, all can be used to measure using a Hall effect transducer. So here the option will be all of them mentioned. So option D is the right answer over here. Okay. Then we'll go to the next question, question number 97. In the Hall effect, the directions of electric field and magnetic field are parallel to each other. Now this statement is wrong because the direction of electric field and magnetic field are perpendicular to each other. Okay, so this statement is wrong, so it is false. It is false here because electric field and magnetic field are perpendicular to each other. Then we'll go to the next question. In the Hall effect, the electric field is in x direction and the velocity is in y direction. What is the direction of the magnetic field? So when we say electric field, magnetic field and velocity, these three are mutually perpendicular to each other. Okay, so when they are mutually perpendicular to each other, if electric field is going in x direction and if velocity is in y direction, then magnetic field has to go in z direction. So here answer C, Z will be the correct answer. Okay, answer C, Z. Then we'll go to the next question, question number 99. Which sensor can detect nearby objects? So here the answer will be proximity sensor. Now these are sensors which emit electromagnetic field or a beam of electromagnetic radiation or any infrared type of radiation. It will send it and it will see what the return signal is going to give. If the return signal is going to give some changes, then it will detect the object within that area. Clear? So this is the proximity sensor which does that, and which does without physically touching the object, it will detect the nearby object. So here answer A will be the right answer. Which sensor can detect nearby objects? The answer is proximity sensor. Then we'll go to the next question, question number 100. The monitoring of machines, gears and objects are achieved by which sensor? Okay, the monitoring of machine, gears and objects are achieved by Internet of Things, IoT, wireless proximity sensors. Again, we have come into the concept of proximity sensor, which will emit a certain electromagnetic field or electromagnetic ray or infrared ray, and it will wait for the return signal, and depending upon the parameters of the return signal, it will sense the object. Okay, Then here the monitoring of machines, gears and objects are achieved by proximity sensor. Answer B will be the right answer. Okay. So here students, I have taken another 20 questions on the subject EMI. You can just go through them, practice them and see that your basics and your fundamentals are very clear. Okay. Thank you students.